Satellites observe the Earth using a range of wavelengths on the electromagnetic spectrum, from short wavelength ultraviolet to long wavelength microwaves. Different wavelengths allow us to probe different aspects of Earth's land, atmosphere, and ocean. Light from the Sun, shining at over 5,400 degrees Celsius, peaks in the visible part of the spectrum. Earth reflects sunlight, but also emits its own radiation at longer wavelengths. With a much lower average surface temperature of 15 degrees Celsius, Earth's radiation peaks in the infrared part of the spectrum. Many satellites use the reflected visible and the emitted thermal wavelengths to probe the planet's surface. The atmosphere scatters light at shorter wavelengths, sometimes making it hard to see the surface. We can often get a clearer view in the infrared. Growing vegetation strongly reflects near-infrared light. Surface temperature controls emissions in the thermal infrared. Satellites are also used to probe the atmosphere. Atmospheric gases absorb light at characteristic wavelengths. Sensors are tuned to the unique absorption patterns of different gases such as ozone, carbon dioxide, and water vapor. At longer wavelengths, water vapor blocks most of the signal from the surface, but we can still gather some information about the upper atmosphere. The atmosphere starts to clear again at microwave wavelengths. Microwaves emitted from Earth's surface tell us about soil moisture, ocean salinity, snow and ice. While some satellites tune into these emissions, others emit their own microwaves in the form of radar beams. Radar altimeters precisely measure the height of the ocean, glaciers and ice sheets. Scatterometers measure ocean roughness and wind speed. Synthetic aperture radars can take detailed images through clouds and at night, allowing us to continuously monitor vegetation, water bodies and ice flow. By sampling the electromagnetic spectrum at multiple wavelengths, we can build a more complete picture of Earth's complex climate system. With 23 climate variables and 40 years of satellite observations, ESA's Climate Change Initiative is tuning in to Earth's climate.